Assalamu alaikum wa rahmatullah. May God Almighty protect you all from coronavirus. Please, my dear students, take your precautionary measures. Today we'll continue explaining chapter number 5 in electricity entitled DC voltage. At the end of this video, you will be able to measure the voltage of a DC generator or a receiver using an oscilloscope, and also you will be able to read an oscillogram. All what I need from you is to bring your notebook, your pen in order to take some notes, and your smartphone or your tab. This is the electric circuit. It is made up of a generator or a dry cell or a battery. This is the lamp, these are the connecting wires, and this is the multimeter, which serves here as a voltmeter. This voltmeter allows us to measure the voltage directly to the electric component, such as the lamp. It has two terminals that come connected to the lamp, then to the negative pole of the dry cell, while the V-com is connected to the lamp, then to the positive pole of the dry cell. And as you know also that the voltmeter and the lamp must be connected in parallel. This is the schematic drawing. Here is the symbol of the generator, the electric wire. This is the lamp, and this is the voltmeter with its two terminals that come to the negative pole of the dry cell and the V to the positive pole of the dry cell. My dear students, do you know that there is another instrument that allows us not only to measure the voltage but also to visualize it? Yes, we have. It is the oscilloscope. This oscilloscope is an instrument. It allows us to do both functions, to measure the voltage and to see this voltage on the screen. So please keep this in mind. Start copying it in order to be memorized. This is the screen of the oscilloscope. It is made up of two axes. This is the vertical axis. It represents the voltage U. And this horizontal axis, it represents the time. Each square on the grid represents a division. Its unit is div. This small dash is called subdivision. It's almost equal to 0.2 divisions. These are two oscilloscopes. These are two signals on the oscilloscope. This is a luminous line and this is a luminous wave. These two signals produced by the oscilloscopes are called oscillogram. So this is the oscilloscope, this is the oscillogram, oscilloscope, oscillogram. This is the screen of the oscilloscope. And to the opposite of the screen, we have a lot of buttons. For example, this is the switch button. This is the phase pole of the oscilloscope. And this one is called the ground pole. This one is called the SV button or the vertical sensitivity. We will talk in details about this button later. Let's have a look over the connection of the oscilloscope to the terminals of the generator. The positive pole of the generator or the dry cell is connected towards the phase pole of the oscilloscope, while the negative terminal of the battery is connected towards the ground pole of the oscilloscope. So the positive pole to the phase and the negative pole to the ground. This is the schematic drawing. This is the symbol of the phase, while this is the symbol of the ground. As you see, the phase must be connected to the positive pole of the dry cell, and the ground must be connected to the negative pole of the dry cell. Please keep it in mind. Now, what we observe on the screen of the oscilloscope is given here. In case that we do not have voltage, or in the absence of the voltage, we observe a luminous spot in green at the center of the screen. So here is the luminous spot in case that the voltage is none. What if we have voltage? For example, we want to connect a 5-volt battery to the terminals of the oscilloscope. Here, my dear students, we have to differentiate between two cases. Case number 1. We have voltage, but the sweeping is off. The luminous spot, which was at the center of the screen, it moves above this center. So, in case number 1, when the sweeping is off but the voltage is present, so we see a luminous spot at the center of the screen. What if the sweeping is on? The luminous spot changes into a luminous horizontal line above the x-axis. Here we have an example of 3 batteries, battery A, B, and C. They have different voltages. Battery A, its voltage is 2. Battery B, it's 4. And while battery C, its voltage is 6. These are the 3 oscillograms. As you see, all these oscillograms are about a horizontal luminous line. But we have a difference here. As you see, that this luminous line is shifted above the x-axis by 1 division, while the second line is shifted by 2 divisions upwards, while the third line is shifted by 3 divisions upwards. So, as you notice, as the voltage increases, the number of vertical divisions, or what we call Y, also starts to increase. So, we can say that the value of the voltage is proportional to the Y. It means that as the voltage increases, Y increases. Here we have SV. It is called vertical sensitivity or vertical amplitude gain. It is about a button on the oscilloscope. As you see, 2 volt per division. It means that every vertical division represents 2 volt. Now, since the value of the voltage is proportional to Y, we can get this rule. U equal SV times Y. U is the voltage in volt, SV is the vertical sensitivity in volt per division, and Y is the number of vertical divisions in diV. Let's have this example. This is the button of the oscilloscope. Is called the vertical sensitivity. As you see, it is adjusted on number 2. So SV is equal to 2 volt per division. And this is the luminous spot is shifted upwards by 2.5 divisions. 1 division, 2 division, 2.2, 2.4, and this is 2.5 division. Then we get the value of the voltage this way. U equal SV times Y, 2 times 2.5 equals 5 volt. We have another application. Now we have to match the value of the Y, the number of the vertical divisions, to its corresponding oscillogram. As you see here, we have 3 oscillograms. The number of the divisions here is equal to 2 division. This one, as you notice, that the luminous line is below the x-axis, so the Y is negative. So Y here it's equal to minus 1.2 divisions. Here, Y is above the x-axis. It is equal to 1, 2, 3, 3.2, 3.4 divisions. This is our matching. Here we have another application. This is the SV button adjusted on number 10. So, SV is equal to 10 volt per division. This is Y, it is equal to 1, 2, 3 divisions. Then we get U equal SV times Y. 10 times 3, it's equal to 30 volt. Another example, now we want to calculate the value of U. This is the SV. It is adjusted on number 5. So SV equals 5 volt per division. This is the oscillogram. It is shifted downwards by 2 divisions. Then Y equals minus 2 divisions. Therefore, U equals SV times Y. It's equal to 5 times minus 2 minus 10 volt. Now you may ask, why does the luminous line move downward? The answer is simply right here. Look at the connection. The positive pole of the dry cell is connected towards the ground pole of the oscilloscope, while the negative pole of the dry cell is connected towards the phase pole of the oscilloscope. When the connection is reversed, then the luminous line will be shifted downwards. This is the summing up. The role of the oscilloscope is to measure and visualize the electric voltage with time. The DC voltage means the voltage that does not change over time. For example, the voltage across the battery. This is the rule, U equals SV times Y. This is the symbol of the phase, while this is the symbol of the ground. When the sweeping of the oscilloscope is off, the spot moves vertically upward. When the sweeping is on, we get a luminous line which is shifted upwards or downwards depending on the connection. Could you please answer the following two questions? This is exercise number 1 and this is exercise number 2. And finally, I want to thank you all for watching and have a nice day.